So like we're saying, you don't need to be an engineer. Being an engineer can be daunting at sometimes. You know, there's so many different things you can learn as far as software engineering. We're going to talk about a lot of different technical stacks today, but it does not make sense for everyone to say I need to be an engineer. And kind of just to preface that, I did this at a time before we had product managers, and my job was a pain in the ass. So my job used to be product management. Is UX, design, give tech, work. There was no product manager in the middle, and it sucked. So now we're in a pretty awesome time where people like Catherine sort out this crap, and it gets to me, sorts out the crap with the client, crap with these features make no sense. Yes, you need to have a reset password functionality if you have a login functionality, stuff like that. So I'm not constantly fighting people. We're just giving in and saying, fine, we'll go to it to make sense. So really, really great to have product managers now around. I would not come back to an agency if there weren't product managers, because it's just miserable. So you don't need to know, but you know how to speak it. So software engineers can be difficult to work with. I'm pretty friendly and straightforward, but not everyone is. So the more you speak their language, the more you understand what they're dealing with, the easier your time will be. Because at the end of the time, the majority of your agile team is going to be software engineers. And the role I'm in, 25% coding, 25% reviewing code, 25% team management, 25% anything else in the project. So I'm a software engineer, and I only code 25% of the time right now.
Matt, if there is an engineer who doesn't really speak or is not friendly, like what are some good ways of how you can kind of break the ice with them and kind of as a product manager?
Sure. A lot of times there are certain people who just aren't sociable or want to talk. They just meet phenomenal software engineers who aren't friendly. And the best thing you can usually do, I don't know about breaking the ice, but the best thing you can usually do is just give them really well-defined working tickets. So I have people who pretty much just might not want to talk. They just don't like to talk to people too much. But if you give them really clearly defined acceptance criteria in a ticket and good designs, and they just want to put on headphones and work for 3 hours, they might be phenomenal. So that's probably most developers. Just one clear set of instructions on what they need to do to solve a problem instead of, let's have an hour meeting about the problem. That'll piss them off. So the big thing I do is try to minimize my whole team's time in meetings. So I usually say, hey, product manager or project manager or UX team members, meet with me and I'll help work it out. And if we have to go to the team, we'll go to the team because they have commitments to do this sprint. And it took me a while to realize that's actually the most valuable thing I can do on a team as opposed to code. That took me a long time to finally admit that. Implications of the decisions you make. So technology work is expensive. It's really, really, really freaking expensive to run a Scrum team. So when you make product decisions, think about it as, you have points are your currency. You want to be really careful how you spend them. That's the biggest thing I would say, is that they are a finite resource, and it really matters where you spend them. Because if you spend them in the wrong places, the results are terrible, and you might not get a second chance. Especially with client services work like Catherine and I do. So obviously, y'all work at this. Let's learn to speak it. So, like I said, there's so much technology out there. I don't even specialize in just certain stuff. And you'll quickly kind of realize that the more you know, the more you know you need to know is the phrase. Like in my project, I used to maintain essentially our whole VM configuration with Chef and Vagrant. And I can go into that. I just have to stop doing it because I'm not as much of a DevOps person. I'm much more like a back-end software engineer architecture person. So that's an example. Or with the front-end work, I used to try to review all the HTML and CSS in the project. I don't do that anymore because I'm not that good at it and I'm not up to date. I still occasionally review JavaScript, but in general, there's so much out there. So what I'm going to talk to you guys about today is just the tip. So, of the iceberg. So if you want to dive deeper into anything, by all means do it. There are certain things where we get more into front-end work, more into back-end work, more into automation, more into automated testing, and things like that. But I would say don't get overwhelmed and ever feel like, oh, there's so much, these tech guys and tech girls know everything. How can I ever know that? We don't know everything. I frequently Google stuff all the time, all day. So don't ever feel like it's an insurmountable thing. Cool. So, technology stack. What does a tech stack mean? There are choices. You're choosing what you're going to build. You can choose what you build it with. You can build a house out of concrete, wood, brick, whatever you want. You can choose what you want to build it with, or you can live in a tent. So a technology stack is a choice of saying, at the end of the day, which set of products we want to use, technology products, to build a finished product. And some are older, some are newer. The government likes some, startups like other ones, different countries like different solutions. It all depends on what your background is. So before we get into tech stack, how does the internet work? So the one thing that I always ask in interviews for technical architects is around HTTP. Does anyone know what HTTP stands for? Yep. Every single thing on the internet that talks to every single other thing does so through HTTP. So when you type generalassembly.com, that sends an HTTP request to a server via the network and DNS, and then that server then responds with a set of HTML. And then that HTML has assets in it like images and style sheets. Your browser then makes other HTTP requests to ask for them. So all a technology stack really is the set of tools that deliver an HTTP response. So you say, I would like this thing from the internet. Goes out to the network, it looks up generalassembly.com, says generalassembly.com's IP address is this. We go to that IP address, and that IP address says, hey, somebody wants something. I'm going to give it to them. A technology stack is just what gives them that HTTP response. So the technology stack delivers HTML, CSS, JavaScript files, images, videos, and everything else. And then also coordinates all of the kind of back-end type stuff like databases and caching and things like that is all part of the technology stack. So any technology stack, PHP, Ruby, Python, Rails, Java, .NET, as far as the internet's concerned, is just delivering HTTP responses. And HTTP works the same across any tech stack. So that's why I would say it's the most important thing to know. So a little bit of what I just talked about, router, modem, ISPs, DNS, servers, and scripts, is that, and it's not just websites either. When you have an app, and that app talks to a server, that's also over HTTP too. So it transcends even just web. We used to do a lot of native applitions, which are like, I'm going to make an application that only runs on this computer. So, I don't even know the example. We use HipChat, where we actually have the HipChat client installed on our laptops. Most product development you guys are doing is probably not going to be that. It'd probably be web-based software or apps, both of which will use HTTP a lot. I don't really go too into this, so I guess just as far as what I explained to HTTP, we have a kind of a general understanding of you have a client, which is essentially a laptop or an app, is asking a server for a resource, and then the server delivers that resource. Is that kind of outline roughly clear? Okay, and that's it. And those resources essentially are instruction sets. HTML is an instruction set for how to structure your content. CSS is an instruction set for how to make your content look. JavaScript is an instruction set for how to make things work in your browser, and that's it. I mean, those are really what get delivered. There's back-end languages that actually talk about what is in those HTTP responses, and will dictate kind of the content that's served back, and we talk more about that too. If there's any questions, just please, we can add some at the end, but just raise your hand and I'll follow too. Cool. The stack, front end and back end, the big thing. People usually specialize. When I was younger, and this work was less complex, I did both. And then front-end work got much, much more advanced, and back-end work got much, much more advanced. So usually a lot of times you'll see developers specializing in one. Your team at Columbia, are they mostly split up, or are they?
Totally split up.
So they're
It was interesting, though, Wedding Wire, I never understood the concept of front-end and back-end specialized developers until I came to Huge. Because Wedding Wire, each one has to do both.
So I worked at another large company, Webs, which got bought out by Vistaprint, so it's like the Vistaprint branded build your own website tool, and that's the same thing where we say a single developer has to own a feature, so you have to do front end and back end. And there's really senior front end people and back end people who will help you. But it's kind of nice to have the autonomy to build the whole thing by yourself. So like I said, front end is HTML, how content is structured, CSS, what it should look like. You ever hear the terms less or Sass? Those are CSS precompilers. So CSS is actually really limited. So what you can actually do is write a much nicer language that compiles down to CSS. So that's what you'll hear those. And then JavaScript is what happens when I click this button, how does this menu work? You ever hear terms like TypeScript, ECMAScript, or CoffeeScript, the same thing where JavaScript is kind of older language. So they're languages that actually compile down to JavaScript that makes it kind of more fun to write. I still just write JavaScript when I do write JavaScript for the most part. Backend. So backend is, for the most part, when you hear that term, really only three things in my mind. It is your programming language, a web server, and persistence. So web server would usually be Apache or Nginx, so you see a lot of for the most part, and that's actually just a way to deliver HTTP responses to a browser. So that's the answer for your call to get something from the server. And then your web server will pass off stuff to a programming language. And that would be something like PHP, Rails, Python, Java, .NET, or Node.js. And that's actually where the native application's logic are. That says like, hey, when someone goes to / product management, we actually want these things to happen in code. So that's actually the part of the application. So you essentially usually, like in Rails, for example, you have a controller and a routing file. And a routing file will say, okay, when you have /product, then here's some extra code that says what products to go grab. Pull those into this page and then serve them back in HTTP response. So far we've got web server, we've got programming language, and then the last part is persistence. And persistence is usually just a database. Or it can also be caching mechanisms. So stuff like MySQL, PostgreSQL, SQL Server.net are kind of more standard databases. Lately you'll get into more what's called NoSQL databases or key value store pairs, which are things like MongoDB or Redis or stuff like that. Just different ways of solving the same problem. Kind of more advantages to some of them versus the others too.
Why is it called persistence?
So the thing is, it's data that lives on between requests. So essentially, if I create variables in my code, those variables, usually depending on the framework, are just gone after that request. So it's a way of keeping a value for something. So it's a way of, I signed up, I need to store your email in a database. And so yeah, it's usually just a database, is the easiest way to think about it. Another thing the backend will do a lot of lately is actually call, the backend and the front end, can call APIs. So more and more applications you'll use today will actually not have their own databases, or they may have a very small database, but will also just use third-party services. So an example would be Facebook login. You could actually implement just JavaScript to do Facebook login, or you could actually do it through the backend as well. And then maybe you don't have to write your own persistence for users in your database because Facebook just does it for you. Good example of how to do that. Tech stack, a little bit of this went over. The front end is the client. When you hear the term client, it's either going to be a web page or an app. The client asks for things via presentation layer, which is native app code or HTML, CSS, and JavaScript. Goes to the server. Code the database, that's the persistence layer, and that's the back end. So any questions so far on kind of front end versus back end? Okay, there's been a real. Go ahead.
Can you talk really quick about what is important as a product manager for understanding the difference, if you kind of know where I'm going?
Sure. In general, I'd say front end work is usually easier to change a little bit. So things like, I kind of want, not always. Like, I want to change what color this button is, or I want to change, how this navigation works. Not to say that all front-end changes are small changes, but in general, they're a little bit easier. Back-end changes can sometimes be more complex, because I'd say a few reasons. You may have to change, let's say you have 10,000 records in your database and you realize you're not storing them correctly, and you want to make a change, you might have to update 10,000 records and not just push your code out. You then have to push out code and update 10,000 records at the same time while the system is live, which would be true. Versus I just want to push out a new CSS file, which is just that. And in general, both can break stuff. If you break things visually, you'll know very quick. If you break things in the back end, you might not know unless you have automated tests, which I'll talk a little bit more about it. And another really interesting thing too is a lot of work that was done on the back end previously is now done on the front end. So a lot of what you'll hear we'll talk about are like single-page JavaScript applications. So it used to be very much you'll see web pages constantly loading as you're doing stuff, like full pages. And a lot more what you see now is JavaScript making calls to APIs in the back end and swapping content out as you browse. So like I use RDO for music streaming, and that thing never refreshes RDO.com. It's just, you're constantly swapping in new content and things like that. So that's why JavaScript has become like super, super hot lately. Just because there's so much more work you can do in the front end now, it's easier to. To do front end work, you just need a browser. You can all open up your browser right now, write some JavaScript on your computer and run it. To run a complex technical stack in the back end could be a day or two of setup. So the barrier to getting into work is much lower for front end work than back end work.
One difference for the front end work versus back end. Front end you can show and demo easily because you can see it. With back end work, sometimes we've been working for months and there's nothing to show just because you've got to show code, right?
Yeah.
So,
Yeah, good point. And a lot of times for products, I don't know, if you guys talk about prototyping at all? A lot of times you'll just prototype stuff in just JavaScript. So it's a really good way that a client says, I want this. They're like, are you sure you want that? So you spin up a prototype quick for them to play with it, and then they can see if they actually want it or not.
First off, thank you for pronouncing NGINX. I never used Nginx, so thank you. I'm embarrassed now that I didn't.
what did you call it?
Nginx? Like a,
Nginx, yeah.
yeah, nice, very good. So, can you tell me a little bit about the difference between Nginx and Apache?
Sure. I love Nginx compared to Apache.
Written by a Russian guy?
That's what I thought.
Yeah, Nginx is, what's cool about Nginx is it's much, so Apache is much more older style. It's what built most of the internet. But the way you write the rules is very like configuration for a server. With Nginx, the way you write the rules is very much like code. So of course I like it. So like, think about like a logic block or an if statement is like, if this thing is true, then do this. Nginx is much more like that. If this matches this URL, then do these special things. Apache is much more kind of does not look a programming language to me. So it's much less intuitive to a programmer. So like for example, in Nginx you can use regular expressions, which are a way of identifying patterns. They're natively built into Nginx to say like to match an advanced URL pattern with multiple variables. Whereas Apache, that crap is just miserable to do.
Yeah.
So yeah, that's the main difference. And there's Microsoft IIS is another one, and there was one or two other small ones too that come to mind.
And for those who don't know what's Nginx or Apache, would you tell what that layer is in technology stack?
Sure. So that's the last layer that talks to essentially, that serves the response back to your browser. So it also receives a request. So a web server runs on a port. So somewhere on the internet right now is every single web server, and they all have port 80 open. Port 80 is listening, saying, does anybody want anything? Does anybody want anything? Does anybody want anything? Then a request comes in, it's, okay, cool, I've got a request. It's going to look at that request, do certain things, and depending on the URL that was requested, it can possibly pass it off to a programming language. So if you ever see .php in a URL, it's probably a PHP application. So then it passes it off to the programming language. It does this kind of stuff, it calls the database, it calls some APIs, it says, okay, I've got everything I need to do. It passes it back to the web server. The web server says, okay, I've got a full HTTP response, and then that serves it back to the client. UI layer, the user sees, interactivity, just how things work. Data, backend, server, code, database. Not the most exciting slide. Should have this one. Example tech stack. So the UI layer, almost anything web-based will be HTML and CSS, like I talked about. Interactivity will always end up being JavaScript. You can use some subset of JavaScript. Data can be managed via JavaScript or the backend. Server, we talked about that. So this box right here for a server, you can actually have different companies run this for you. So when we talk about, I could make my own web server and run it, it'd be crappy. Or I can just go pay Amazon and say, hey Amazon, give me a server for $3 a month and it'll be phenomenal. Amazon won't really manage it for me though. So I'll have to actually patch my web server and everything else like that, the underlying operating system. Company like Rackspace will actually just patch all that for me and update my web server. Hey Matt, there's some huge security bug in the new version of Rails. They'll update it for me. So that's the big difference when people talk about part of the tech stack is who actually owns it. Bigger companies will run it themselves. So if you're Facebook, or actually I don't know what Facebook does, but like Netflix, for example, uses all Amazon's technology as well. So even they don't want to run their own technology stack because Amazon's got faster connections as part of it. So a lot of times you pay for a host. That's commonly called a web host. So if you buy web hosting, you're buying a whole server or you're buying a chunk of a web server that's got a lot of smaller partitions on it for you if you ever buy web hosting. So like my web hosting is with HostMonster and it costs like $8 a month or something like that. And different hosts specialize in different technology stacks. So there's ones that just do Microsoft technology, there's ones that do Java technology, Rackspace does PHP and Rails really well, Heroku does Rails work really, really well, Engineer does Rails work as well, pretty good. So there's different choices you'll make there. Some hosts will do multiple ones, but there's commonly a host who specializes in what you want to do.
Who makes the choice and when do they do it?
Yeah, good question. So as soon as you need servers. So I was at a startup and we had nothing. So I said we need pre-production servers. So I said we need dev, QA, and stage. So I built those racks with Amazon. So I configured everything because they don't really matter. they're not going to get a lot of traffic, whatever. I'm not a good server admin. So I made all those on EC2, but then when we had to launch the application, I said, hey, let's go pay Rackspace. Then we paid Rackspace like $600 a month. Then they actually run the production server for us, and they'll, get a call in the middle of the night if something's down and fix it rather than me. So that's the choice for the most part. Some common words. Shout out any know.
We talked about S3, the Amazon server.
Java, Perl, Bash, 3.
What's Hadoop?
Like a large data type platform, similar to Solar. I haven't used any Hadoop. Some of the weirder ones here, Azure is Microsoft's cloud platform. Not a Microsoft person, haven't used it. SSL, secure socket layer. When you see HTTPS and the green lock in your browser, that's actually a special form of HTTP requests and responses. So normally, this call goes plain text over the internet. So for a long time, if you were at a coffee shop and you were logging into Facebook, your cookie value went back and forth as plain text, and anyone could log into Facebook as you. So if you're going to turn SSL everywhere, that's saying this all needs to be encrypted completely. AWS and Amazon Web Services, Perl, the programming language you'll ever run into. Java runs most big things on the internet, like banks and stuff like that, financial institutions. Jenkins, I'll talk about that with DevOps, that stuff. S3 is Amazon's storage platform. That's if you just need somewhere to store a lot of stuff and never store it yourself. Heroku is a really good platform where you can just push code to Rails that'll run. Bootstrap is like a CSS framework, so if I start with a browser from scratch, it's going to be black and white times 0 and it'll look like crap. I can start with Bootstrap and it's going to look really nice. My buttons will look nicely formatted, things like that. PHP is what I specialize in. Used to be terrible. That's gotten better. Luckily, in the last couple of years, there's better frameworks for it now. It used to be completely terrible. But it runs a lot of the internet, so there's a lot of it everywhere. SQL, structured query language. JavaScript framework I'll talk about. And MongoDB is a...
Facebook's on PHP, right?
Yes, they have a crazy... They write PHP and it gets recompiled to optimize C. So they essentially re-engineered PHP so it runs much faster than it does. PHP's got a lot of things that are like dumb about it, but they'll stop it from working. There's a lot of things that, like, from a design perspective, you could look at Ruby and PHP and be like, well, that's a dumb way to do it, but it still works. And it's easier for non-technical people to pick up too, for sure. Whenever all this stuff, HTML, CSS, and JavaScript, back-end development. Technology PMs use. A couple important things we're going to talk about too. GitHub is version control. So how it used to work. I remember when I was in college and there was an assignment, and it was a team assignment for 3 people. We all have to work on the code. There was like 2 options. We kind of all work together on the same computer, or you work on this and I email it to you as a zip file, and then you work on it and I work on it. And it was crap. And I remember we used CDS for the first time. So all version control really is actually, it's pretty complicated.
I always compare it to Google Docs. You know how you have revision history? So it's pretty much the same thing. Everybody works on the same files, and you can see revision history. But it has much more complex, where you can compare, like, you can see by person and how everything's aligned.
Yeah, I mean, the thing that's nice about this is there's a master correct copy. It's not who had the most up-to-date copy on their laptop. It's, no, the master copy is here, and you can actually see a whole record of who changed everything at what time. So when something breaks, you can be like, oh, who broke it? It also gives you a really nice way to do differences, diffs. So a lot of times you'll hear developers say, okay, I'm going to make a feature branch. What that means is they're going to take a copy of the code, make their own copy of it, make some changes, and those are on a feature branch, and then they actually create what's called a pull request. And the pull request says, hey, I've got these changes, I'd like to bring them back into the master copy. And then what you can actually do is, I'll show you like a diff, for example, in Stash on my laptop after this. It shows you the differences. So you can see exactly who introduced what changes. So that's how we do code review. So a developer on my team will take a feature, they'll take a ticket. They'll assign a JIRA ticket to themselves, they'll develop it on a feature branch, then they'll make a pull request, and they'll add me as a reviewer. And then it's on me to actually review all the code in the pull request, and I can comment on it. So it's a really great way of making sure something stays the way you want it to, and having accountability. There's actually a push to use GitHub and version control for laws in the US, because then you can actually see which politicians introduced which lines to a bill, which would piss a lot of people off and make them much more honest when you see, oh, this person contributed money, their campaign was financed for this person, and they put these lines in this bill. That'd be nice, but not yet. GitHub is the most popular solution for this. So GitHub's been just fantastic for everything I've ever used it for. Before GitHub, so GitHub is a very easy way to use Git. Git is the underlying version control technology, which you don't usually want to run your own Git server. So you have GitHub do it for you. Before GitHub, there was SVN, Subversion, which you'll sometimes hear. Some large institutions still use Subversion. If you ever hear Mercurial or Bitbucket or Stash, those are all different versions of the same thing. In general, if you go to like public projects in GitHub, there's a lot of commenting on features and specs. You can talk about features. I don't like to do any of that in GitHub. I like to keep it all in Jira. So if you're a PM, it kind of stinks to say, and your developers say, oh, we figured out the solution, and it's in GitHub, and you didn't know what they were doing, or the designs were on the Jira ticket, not on the GitHub ticket. So you can manage bugs and stuff in GitHub, but it's not quite at the point that Jira's at or other project management software. I've done it once. I worked on Ride, and I was not pleased about it. I was like making all kinds of tags to do point estimates and stuff, and it was just not the best.
It is important to know, like, if your developers are using GitHub or Stash, because they will put things in there, and sometimes if you feel like you don't know really what's going on with a feature, you can find it in GitHub or you can find it in Stash, and you might find more information if you don't want to bother people about it. So.
Yeah, a lot of my job too is we want to release some code to production. I need to really carefully look through GitHub or version control and Jira to figure out what we're actually launching and make sure there's no conflicts or things like that. And the other thing you'll get with this too is, let's say I'm working on a feature in code, Kyle's working on a feature in code, we both commit our changes, they can maybe conflict. The version control system will tell you, hey, you guys both touched the same file recently in the same lines, there's probably a problem here. And then one of us have to resolve and commit before we brought the code in.
The other thing too is, since this is a code repository, and if you are familiar with coding a little bit, you can learn how things work on the back end, because that's where all the code lives, so you can kind of look at what files are, like, if you want to see how something works.
Yeah, so my policy in my teams is anyone's allowed to code. So we have a product manager who writes code in New York City right now, and we have a UX person who prototypes. He'll do the prototypes, and then they're pretty good, and we'll take those as a starting point for the actual features. So all code is reviewed on my project, so anyone is allowed to code, and that could be just a configuration file where you're updating some copy. Why shouldn't a product manager be allowed to do that? So I really kind of ask your development team, hopefully it's pretty friendly, to say, hey, I would like to kind of work on the code base. Can you help me do that?
Sure. So what if maybe two questions. Does GitHub, can they see your codes? And then number two, what if GitHub goes down? Like what? I'm just curious, GitHub is huge.
Then developers get a break.
The GitHub Angry Unicorn, I guess goes down. I forget what it is. Two good questions. So if you sign up for a GitHub account, by default, you have to have public repos. So by default, everyone can see what you're doing. If you pay for a plan, then you can have private code. But in theory, yes, you are trusting GitHub to look at to not do anything with your code. Some pretty large organizations trust them. I wouldn't be too worried about that. And yes, when GitHub goes down, you can still work, but you can't pull anything from the server. So you essentially have a copy of the entire Git repository on your local machine, but it might not be up to date. So if Catherine pushed some changes an hour ago, GitHub went down, I pulled the repository back down, then I'd be screwed. And there are times now when GitHub's been down, and we just gotta spin around in our chairs. Yeah.
But your production site's not
Correct.
using the code in GitHub the same way. It's like calling the Amazon servers.
It's just a library.
Yeah, the really important takeaway is we talked about dev, QA, and stage here. What those are all doing is taking a snapshot of the code that's on GitHub and putting it onto the server. So your deployment process will say, I want the code at this specific point in time in GitHub. You can give it like a commit hash or a version tag number and say, like, put this version on the machine.
Is there any reason that GitHub doesn't have a local implementation or plans to pursue that? Like if you wanted to take it off of their...
I think there is a GitHub Enterprise where you can run GitHub yourself.
Oh, you can?
I believe so, yeah. There's also, like I said, I mentioned Stash. So we use Stash at Huge. And I'm not sure. You can either run your own version of something like Stash, or run your own Git server, or pay someone to do it. The bottom line, though, is that it's someone's job to then patch and maintain the Git server. Right. But if you are really scared about someone getting access to your source code, you would run your own Git server instead. But the trade-off is it's now someone's job to fix it, and it will probably go down more than GitHub. SQL, we talked a little bit about this, which is just structured query language. Have you ever seen select star from, so for example, let's say when I log into our website, we have my email. You write an SQL query that looks like select ID, comma, username from, the table name would be users, where email address equals me@matt-guido.com. So that's essentially, for a long time, how we always asked for content from a database. Very, very useful for pulling analytics. There's so many places that have large collections of data, and more jobs now are just making sense of that data. And SQL is pretty cool because it's universal across a lot of products or very close to it. So if it's a Microsoft shop, it's an open source shop with MySQL or PostgreSQL, SQL looks very, very similar. So it's very easy to pull large collections of data from these large data sources. Yep.
Another one I don't know how to pronounce, Postgres, is that right?
Yeah, I say PostgreSQL. I could be wrong too. Cool. So this is the language where you usually ask your persistence layer, your database, for things you want. Like I said, a lot of really cool analytics work and visualization works this way. When you guys see really neat visualizations, those started with someone usually writing SQL or a similar type of language you'll get into to pull the data they want. And then from there, once you have the data and the conclusions from the data, you can then make beautiful visualizations. What's very hot lately are what's called NoSQL databases, which are things like Mongo. The problem is, let's say I have 1 million user records in production. This is actually a true story. Where I was, there's several tens of millions of records in production for users. And a alter table statement means I want to change this field to another different field, would take weeks. So yeah, so we stopped using the existing database solution for that and started using Mongo more. So Mongo essentially will store data in any format you put it in. So it's no longer, here's the strict rules for a chunk of data. It's you can kind of do whatever you want for the most part, and you have to have your application work that out. So you can start changing how your data goes in, but you have to manage that more carefully through your application. And a lot of what you do then is your database can have rules saying you need to have these fields in it. Those rules then move from your database enforcing those to your application layer like Ruby on Rails, which I like much better. So I'm a software engineer. I don't always know the rules in the database, but I sure know the rules in the code base. So you'll see a lot more of that lately. The Rails projects I have worked on all actually use Mongo, luckily. So Jira, I'm sure Catherine's been showing you our actual Jira, which is kind of funny. That's a real deal Jira instance that runs, I don't know, 1,000 projects probably.
Oh yeah.
At least there's like at least 1,000 projects going on in that Jira instance. Knowing Jira alone can get you a good job, I think. Because just knowing the biggest thing with Jira is
Matt's,
go ahead.
Matt's its biggest fan.
I am, yes. These are the things I've got to avoid.
Projects that don't use it are doomed for failure.
Not always, no. So there's a couple of things Jira gets you. The biggest thing is it's a list of things to be done, and at all times someone's name is assigned to those things. It's never, this was all of our responsibility. It was someone's responsibility and why the hell didn't it get done. If I need clarification on product, I'll assign a ticket to Catherine, or things like that. And the other big thing it gets you is you can actually write SQL-like query language to pull Jira tickets. So if you're a manager managing 3 projects, you can make your own dashboards that show me which tasks are overdue on those 3 projects, or things like that. Or what are the critical bugs for my 2 projects that are due next week? You can write those kind of reports. And then if you're more of a business analyst type person, you can actually see the time flow of login tickets. You can say, okay, Matt thought it was 4 hours, but he logged 3 hours. Your team's logging, stuff like that. And then you can have discussions there via comments and things like that. And it really just makes a lot of decision-making visible, and accountability is the big thing about it. Is when you do stuff in email, it gets lost. So I'm always like, people are like, oh, there's a problem with the server. There's like 20 emails. I'm like, anyone write a ticket? Like, then this whole email conversation isn't going to make the person who really needs it. So I just like that a lot.
Is there have you found like a cheaper version in Jira?
Jira gets expensive quick, so they get you because the initial couple users are pretty cheap. Then when you get above 10 or so, it gets a little bit more expensive. People use Trello, which I've seen before.
Even for small projects.
Yeah. But that being said, Jira actually might be overkill for some stuff for sure.
Are you using Pivotal Tracker at all?
Our sysops like engineer or system engineering team uses it. I have not used it too much though. You're not a fan?
No, it's missing some, like, I mean, one of the good things about Jira is available on all devices, right? So you can work from anywhere and have access to the same data as Catherine and Chiku has. Jira has all the features. That's why you pay all this money. Pivotal, once you use Jira and you're like, oh, I can visualize all of this, and this is how my backlog looks. Pivotal Tracker, like, kind of does none of it, and the design is horrible. They have the biggest problem with them is their design. Like, it's impossible to compare to anything. So I was like,
It's also nice, like Jira will hook up with Stash. So like you can see, like I can pull up any ticket and I can see, okay, there's a pull request out. So I know that I'm waiting on this developer because he hasn't approved the pull request. But the other, so it's not on this developer because he already wrote the code and sent it along its way. It like integrates with a lot of your other, it integrates with our HipChat because they build HipChat. So I can see like when there's been builds like come directly through your HipChat. You're like, oh.
Yeah, Confluence too is their wiki solution, so you can make like a page describing their product, and then they can filter of Jira issues related to that product feature, things like that. So I use Confluence and Jira constantly.
So we actually use Jira for our data analytics and data science team, and we actually like apply the whole agile mentality approach to that. So I have like daily stand-up with my data team, and we have a product manager who's assigned just to the data team. I don't know if that's common or if you guys have experience or seen that elsewhere, like just kind of taking everything we learned in this class and applying it outside of software development and to like data tasks.
Totally. I mean, I was somewhere where designers refused to use Jira, and now I'm somewhere where the designers want to use Jira. To track where the design works at. So that shift's been massive. And I mean, there's no reason it has to be used just for software development. The only thing with Jira, and I wrote a piece on Qlink about this, is you end up with a punch list of tasks which developers like, but sometimes it's very hard to visualize high-level feature functionality. So a lot of what I'll do is kind of write out maybe some product features in a wiki page that kind of correlates the product features to the actual technical architecture. So it's a little hard to visualize higher-level PM product strategy type planning stuff in Jira.
Yeah, most of our tickets for the data team aren't like user stories, right? They're kind of like, pull this data for this person.
Yeah, so Jira is great, but just don't lose sight of the bigger picture of where your product's heading, because it's like very easy to get into like the punch list mentality. So it's great for organizing nitty-gritty stuff, but also still really plan like at a higher level, for sure.
Yeah, you guys saw last week, I do in Confluence like high-level stuff for the client, especially because clients don't like Jira, or your stakeholders aren't going to look in your Jira, so you have to like manage those things differently.
The thing about Jira too for clients is that their licenses cost the same. A seat's a seat, a seat is a seat. So you're paying for all the functionality of Jira for a client to look at products.
Yeah, that's true. And there's certain scenarios where we have the clients in Jira, or we use the clients. So I'm on a project where we use the client's Jira instance, which means like I get on people's cases for swearing in a ticket, or things like that. Don't do that. You know, or there's other times where we have our own Jira instance that's huge, and then, I mean, there's times when we have to like review a website, and it's political whether we put bugs in it or not. So I'm very transparent with clients. I'm always like, hey, you know, we do good work. There's going to be some bugs. We'll work through them. But yeah, it's definitely something to be aware of if the client is in your Jira instance or not. But more and more clients have their own. It's very common at Huge that will want to do development for a client, start some of these tools up, and then they take them over. Because they realize, oh, wait a minute, website development's not going away. This is one web project that we're not done. So like I had a client, we helped them set up Stash, we helped them set up a lot of these tools well for themselves after we started using them. And with GitHub, it's actually kind of neat. So you can develop the repos your own, then you can transfer them to a client organization. So we do that a lot. So we'll start to code them for ourselves, and the client goes, okay, you did all this work, I want to own it and control it, not have it on the Huge GitHub account, and then we can transfer it to them. That's a very common scenario too. Analytics, huge lately. I tell everyone just to go into analytics type work lately. You can talk a little bit more about this, but I've met a few product managers who were very data-driven, which I really like. So it's like, we should build this feature. And people were like, why? And I'm like, I think so. Or I've had a product manager who's like, no, here's the data we had that shows we should build this feature. I'm like, okay. So Google Analytics is one of the bigger players you'll see. You'll see Mixpanel and Omniture in there. Used to be server-side, now it's more client-side. Tracking what pages you visit, tracking everything. I've done Adobe implementations where we track when you stop on videos, you know, so we can just know when someone leaves a video. and it's pretty advanced at this point. It's tricky to get right, I'd say. It's tricky to implement correctly because developers don't always know what the analytics team wants to know, so they don't always implement the right things. So as a product manager, a really important thing we started doing is looping in the analytics team early on user stories, as opposed to afterwards. So when we release a feature, we're releasing it with the analytics work on it, and we know how to process the analytics data to get what we want, because previously that was not happening. So that's one thing to definitely look out for as a product manager. Say, how does this affect analytics, or can I get, or I really lobby, I spent my points in this feature, can I show what that feature is doing afterwards in a month? It's a really good thing to ask yourself. Scripting languages. If you want to learn to code, Python and Ruby are both awesome. Python is pretty easy. Ruby's interesting. I think it's a little bit different than typical programming languages, but also very fun to learn, and a lot of just amazing tutorials out there. And you can also use it to automate simple tasks. So a lot of data analysis is more and more just programming. So let's say you have 10,000 records and some have some kind of bad email address in them. You know, your developer, your team might say, I don't want to do that. So it's possible for you to actually just write something to process that. Or maybe you want to pull issues out of Jira and show them on your own dashboard. You can hit the Jira API and show the issues on a screen in your lobby, for example. We've done that before. So don't think that I don't want to learn programming because I'm not going to be a software engineer. It's fun to learn and it can help you out a little bit too.
Do you have, between Python and Ruby, do they have preferences for databases?
At this point, pretty much any popular database you can use with any popular scripting language at this point. So it's like Mongo, for example. One of the developers for Mongo was just at the huge New York office and spoke, and his sole job is to make sure Mongo works properly for the Node.js community. That's his full-time job. To make sure it's like, hey, the database connectors work properly. It's very straightforward. The documentation is straightforward. So a lot of database manufacturers will have someone assigned almost to each programming language, and their job is just to make sure it works well with that programming language. Because essentially, if I burn a day trying to get my scripting language to talk to your database and I can't get it to work, I'll probably go somewhere else. So that's all pretty interchangeable at this point as far as those connections. Not going to beat a dead horse. This is the easiest one to learn as a product manager for the most part. Basic HTML, CSS, it's pretty straightforward. Sample tech stack. So I'll show you guys what I work on. I've been technical lead on a project for a hospital for the last 7 to 8 months. So this is our technical stack. I'll run through it. So we use PHP, just it used to be kind of rough, but it's gotten a lot better. We use a framework, which I'll talk more about frameworks in a little bit too, called Symfony. And then we manage dependencies through another product called Composer. So I'll run those two. Apache is our web server. CentOS is our web server operating system. I didn't go over that over there. Should have. Operating system is kind of what lets the web app, your database, all run on a server. It could also be multiple servers. So your operating system on those machines is Mac OS 10. A lot of servers are Linux or Unix, or some servers are Windows as well. Other parts of this tech stack, Jenkins, Chef, Vagrant, Capistrano. I'll talk more about what those are in a few. Persistence layer, Solar, Redis, and Varnish. Solar is like a search technology, essentially. So it's a way of pulling data from large data sets. Redis is a NoSQL data store, so ways of just storing data temporarily. And then Varnish is an actual way to create copies and cache HTTP responses, which I'll talk about a little bit more too. And then the last part of the tech stack is Drupal and MySQL, and then a bunch of REST APIs. So the client manages content inside of Drupal, but then there's also 6 other systems the website talks to, and then those are all just REST APIs the system pulls data from. I'll talk more about what REST APIs are too. So this is one tech stack. A lot of startups you'll see use Rails here. If you're starting from scratch, Rails is a great choice. Some startups use Python, some startups use Node.js right now, which is cool because you can write JavaScript for the front end or the back end. So that's kind of attractive too. Like I said, it's all about what you want to use. If you were at a startup or starting your own startup, everyone says, what should I use? I usually say, use what you're most comfortable with and know the most of. So like none of these choices will usually sink your project. Like it's not going to be, short of like some really odd choices like Perl or Cold Fusion perhaps, that's not going to matter as much as actually building like a minimum viable product, which I'm sure Gavin has hammered into you, and then actually getting feedback on your product. So don't stress too much about the tech stack. If you have an engineer who says, yes, I know Rails inside out, I can build this quickly, go with Rails. If If you yourself know PHP, then stick with PHP. If you want to learn a new one, the best way to learn something new is by building something yourself new, so then maybe try a new one.
Can you talk about like potential for maybe like technical lock-in? I guess if you went down a path with a tech stack, and a year later you hire your CTO or your second person on board, and then they have to reverse everything you've done and transfer it over to a stack. That makes more sense.
Yeah, and there's been cases where certain clients have moved to Java architectures for that reason once they get a large amount of traffic. But my answer to that is, you face that with any technology. The lock-in you'll see isn't usually from a framework choice, it's from a vendor choice. So things like we chose this CRM system, or we chose this CMS system, or we chose this accounting system that's to talk to our website, or things like those are what usually get you, because they'll have some crazy licensing fees. But in general, most of these programming frameworks are free. I don't worry too much about typical lock because any of these are pretty flexible. Microsoft stuff has some licensing fees with it too, and certain database technologies do especially as well. So that's kind of more we should be worried about, is getting, I'd say, financially locked into stuff, right, as opposed to architecturally. It's very common for a startup, I was saying, a startup shouldn't engineer with 10 million users in mind. You should engineer with 100 users in mind and build a fantastic product for them, even if the code in the backend isn't great. So like the first thing you're doing with a startup is proving an idea is correct. Then you worry about how to scale it. So it'd be very common to say like, hey, we built this product, the backend is not really great, but people love it and are paying for it. Then you got more investment money, and then you go, okay, let's re-engineer it a little better. That'd be a very common scenario. A failure would be, let's spend 2 years engineering this thing to be the best, and then we don't know if anyone's really going to use it. Right. So I would not worry too much about that initially, as long as you're getting feedback on what you're building. Is more important, I'd say. Building features. So I've kind of hammered this into you, Catherine, as to the big thing is when we talk about points and sprint and velocity, that's the method developers should use to tell you they can't do something. You're a bad developer if you say, we can't do this. We don't have time. If you say, hey, is everything else in the sprint pointed? Historically, we can only clear 45 points of work a sprint, and you're asking us to do 65 points of work this sprint, then it kind of makes sense, and they have an argument. So I'd say from a product management standpoint, make sure you're doing estimations of point values properly, because that's the mechanism you'll be able to use, and your developers will be able to use to actually tell you if you can do something or not. Because it's very tempting as a developer to look at something and go, oh, it's too much work, we can't do it. And sometimes it is. But until you actually break it down into units of work and estimate it, you can't really say that. Or else you can say it to everything. So, removing features too, same thing. I talked about, you can plan your sprints, but plan a few sprints ahead that we're going to build this thing first, and then this thing. So if you took out the thing in sprint 1 that sprint 2 needed, then who cares about sprint 2? So definitely think about that from a high-level product strategy point. Same thing with delaying features as well. Scope creep. Do we all know what this is? Okay, so before there was Agile, there was SDLC, and we'd say, we're going to build this thing with 20 features. And the reason most of those projects failed is because those 20 features weren't really the correct features, and we learned more as we worked, and the client eventually says, well, I want these other 20 features, or I want these 20 features to be different, and I want the same release date. So what you had was, we want this thing, here's the blueprint, then you add a bunch of extra complex things to it, and then the budget balloons up, the timeline gets screwed, and the project fails. Agile is kind of the answer to scope creep, but you can still get scope creep on your user stories. So, example, I want to see on Google Calendar the events that Matt has this month. We can build that and launch that. So what if we get to QA and someone says, well, we really, really want this to actually let Matt, I don't know, create invites on the same page to those events. And then you say, okay, well, I guess we're not going to finish the story this spring. That sucks. So your team's going to be pissed off, QA's going to be pissed off, your team's going to be bummed they didn't finish the work and do it next sprint anyway. So that's the kind of example of scope creep you guys would run into. The better response is, okay, cool, that's a really, really good idea. Let's write a story for it, we'll put it in the backlog and prioritize it for next sprint, and still deliver the normal calendar page for Matt, and then we're delivering functionality to our users. So with Agile, you guys should always be saying, let's deliver small incremental improvements constantly and gain feedback, instead of trying to build everything all at once. So when you catch people trying to squeeze more stuff onto a user story, just stop them and be like, hey, let's write another story for this. Let's not make this a bug on this story. And scope creep traditionally was just trash so many software projects, and Agile is making it better, but it's not immune. And with Agile, there's places that go through the motions of Agile that actually really do a lot of things. They're just like, oh, we have a stand-up and a retro, but we're still developing to a 500-page spec, which, same thing, the spec's gonna change. Work with your developers. Cool. So, this one's tricky, so good developers don't just write code. Good developers are personable. They'll not say, I just implemented the acceptance criteria. They'll actually help you find issues you might have missed. So I'd say don't ever overlook, like I said, a quarter of my time making sure the team works well. So don't ever overlook your team working well together. So don't ever just go through the motions of doing this, gauge, are people stressed out, are people burned out? Be conscious of hours worked. No one wants to work crazy hours, so it's on you and the team to all collectively kind of prevent that. But yeah, I'd say for the most part, you can do things like ask to help code, or ask them to help you explain things, or ask them to help you define product features. One thing I was doing this morning, I commented on, is before backlog grooming, I work with the product manager myself directly to make sure, because I don't like that backlog grooming takes my whole team's time for an hour. I don't like that. So what I do is I do it before with the product manager, and then our backlog grooming lasts like 30 minutes or so, because I've already cleaned up all the stories with them, and they get estimated really, really quickly. Just in general, people, they're not wizards. We still Google stuff. We still want to go home. We still want to drink a beer. But yeah, definitely gauge the happiness of your team, and don't ever think it's not important that your team is happy. That's it. That one. Really big thing, pisses developers off, not getting brought in early. So as soon as you have designs, ask a developer. Tomorrow, someone has Photoshop documents, and I'm just going to sit in the meeting for half an hour and make sure the breakpoints for the responsive layout are correct. And just me doing that will make someone's job way easier down the line before the client signs off on designs that can't really implement. So talk to developers soon. Look at the problem you're trying to solve and solicit possible solutions. Developers love solving problems. That's what we love doing. So just give us a clearly defined problem, and we can work with you or work alone to solve it, as long as it's clearly defined. Another thing too is, developers are usually experts in this area. So trust them for the most part. I'm very big on hire really good people and trust them, and then be kind of hands off. And then if that's not the case, you're not hiring the right people. So hiring people is the most important thing you can ever do if you're hiring developers. So don't ever settle for developers you think aren't going to talk to you or aren't going to work with you with product stuff. If they say, I don't want to do any product work at all or help you clarify a ticket or functionality, then you probably don't want to work with them. What does X mean? All kinds of extra terms in this room. DevOps, very, very hot term. So we have dev, QA, and stage of production. Someone like me would manually put the code on the servers. So we need to do a QA build. Is Matt out of town? Oh crap, Matt's out of town. He has the shell scripts in his machine to push the code to the server. What do we do? That's one problem. Other problem previously was server team's here, development team's here. Code goes to the server, something's wrong. Both teams put their hands in the air. Third thing was I would be someone who manually configured servers. So I would actually go to my web server and configure everything on the web server by hand. So DevOps kind of solves those three things. The first is it gives people besides developers tools to do deployments. So if you ever hear Jenkins or Bamboo or Hudson, that's essentially a click button solution where someone can click a button and say, okay, I want the latest from GitHub on my server now. So what's really cool about that is it lets your QA team own their environment. So they can say, I'm the guardian of what's on QA, not Matt, not anyone else. This is my environment QA, I can test it. A product owner can say, I own staging. This is my environment, I need to keep it good for the clients, I own it. So it takes that onus off of the developer and other parts of the team as well. And also make sure, let's say the deployment's a 35-step process that I used to have to do correctly every time, now it's done automatically every single time. You have the people who are running the servers. So essentially it's the concept of DevOps, also a DevOps role, or people who are kind of in between. I'm a little bit in between, more software engineer than kind of DevOps type stuff. But it's people who kind of understand not just the code, but also server configuration and deployments and stuff like that. And finally, the biggest thing, the last thing I talk about is server configuration. is a concept known as configuration as code. So previously, configuring the web server was, I would configure that web server and write down 100 steps of what I did. No longer the case. So now I can say, give me an EC2 instance through Amazon, which is a blank server, and then here's an instruction set. Run through that whole instruction set and provision the server for me. So let's say my server got nuked. Gone. New web server, spin it up in a few minutes. So if you heard terms like Chef or Puppet or Ansible, those are tools to describe instruction sets for configuring your web servers. And what's neat is that when that configuration is now in code, you can put it in a GitHub repository. So not just your application, but how your servers actually run is now versioned and can have a pull request. So let's say like when I need to launch some new code and there needs to be some changes in the server, I can review both pull requests and launch them at the same time. Kind of goes along another project, another concept we'll talk a lot about, which is continuous integration and continuous deployment. A lot of agile, so the old model of software delivery was, we're going to do a release once a quarter. That's done. I was somewhere for Hughes that launched 2-3 times a week, which is pretty cool. So that can go from one sprint we have an idea to 1 million users are using it next week. And then you gain feedback. So that kind of stuff is only possible with a really good DevOps configuration. If the old thing too was people would say, oh, there's an deployment coming up, don't do anything new for the next 2 weeks, or we all have to get ready for the deployment. There's no more of that. So DevOps is mostly about not being scared to launch code very frequently and gain feedback. So right now, we launch maybe every 2 or 3 weeks on my project, and I'm constantly pushing for more launches, just to get people out of the phase of preparing for the launch. Yeah.
Can you also do now, like one of my developers was saying that we can, like we just transitioned to Slack because we were on Cato shut down, so you can do chat DevOps, so you can tell Slackbot to deploy things for you.
I haven't done that. That's pretty cool. We use HipChat, but Slack's like super extendable, so you could totally probably just, you could probably tell the bot in the chat room to say, hey, go run my deployment in Jenkins or somewhere else to actually just do what you need to do. So it's things like that.
Yeah.
Those things used to be miserable. They used to be just all manual and just really, really rough. But things like that have made development a lot more fun and easy lately. But the idea is that you're launching code very frequently, and it's possible with this, and this is, Agile is very hard without this. Very, very hard to do Agile at all without the ability to launch code very frequently.
It's coming about from like Facebook or industry starting to do a lot of.
Oh yeah, like Facebook and other places like that, and GitHub. I forget how often they launch. Like Facebook has some really neat things where they run an internal. I believe Facebook runs their staging build internal to Facebook at all times, which is kind of neat. So if you're inside of Facebook, you get the next potential production build at all times, for example. But I mean, these are places like Netflix and stuff like that. All are cutting edge of this stuff. Agencies usually try to push our clients in this direction because we're in a crappy spot if we have to like use an older style deployment process. Government agencies are not really here yet, but they're starting to get here as well in DC. But there's a ton of work in this area too, and it really, really is critical. And it's the kind of thing where when you start to set up a project, you should start with this in mind. It's very easy to start with this. It's very, very hard to back existing stuff into this sometimes, but more places are doing it too. It's hard to get to be fair.
Yeah.
People have a lot of legacy stuff. They have certain pieces of software that can't be automated. They have licensing issues, sometimes even, where they can't actually do it.
Well, you have to change the way you work, too. Like, they weren't agile, so they're also trying to work towards agile and continuous integration. And you have to change the mentality of, like, everyone and, like, how you operate every day works a little bit differently. Like, you work smaller in bite-sized pieces.
Yep.
Goes back to all the agile stuff we've been
Some
talking
large
about.
companies deploy like every 3 minutes. They use such a, like, it's called deployment train, where it, you use something on Jenkins and you just push it and it gets in line, and then, the test run in between every 3 minutes.
Yeah, I mean, if you're not too scared of breaking anything and have really good tests, you can do that.
Yeah.
But a lot of places are not there, or don't have the test coverage to ever be there, probably. Responsive. Does anyone know what this means? We probably most of know.
Yeah.
We used to build the mobile website, and then we used to build the normal website, and maybe the tablet website. Now we build one code base that can be interpreted by all devices. So it's pretty much just saying, we have CSS rules that apply to certain widths of screens for the most part, is all it really is. So when you slide your browser window down, the website switches to the hamburger menu, for example. That's a responsive website. We used to detect a user agent. We used to look at your agency request and say, are you mobile, are you tablet, are you desktop? And then give you a website that was kind of crappy. So responsive is still kind of new. For the most part, like it seems like obvious to us. If you go to a lot of big companies' websites or other organizations or agencies, they're not responsive. So a lot of work you might do in an agile project is a lot of what Huge does is agile designs and making agile designs actually work too. Agile designs, responsive designs. There we go.
I think Pinterest, like, they just had a very good responsive design on their website first. They didn't have the mobile app for a while. And then they got the mobile app, but their design was so good, you could just use it, you know.
I'm a very big mobile web person, so I always tell startups to usually build a really good mobile website first.
Yeah.
I mean, now you have to write for 2 platforms potentially, Android and iOS, but back a while ago it was Android, iOS, Windows 7, and BlackBerry. And I was like, no company's going to do that. Yep.
Is responsive design simply just a reinvention of fluid sites that existed before?
A little different from most of our. There's certain web capabilities, particularly they're called media queries, that came of age a few years ago that let you write specific rules. So fluid design might like adjust, but you could never really have a rule saying if your screen is this size, then do this thing. So it's more just let's scale with this. This is more when you scale to this size, then apply a different rule set, as opposed to just keep scaling bigger or smaller. So you can actually that's what actually makes the menu appear on a smaller screen or things like that, as opposed to just making an image big or small on screen, for example. Unit tests. So this is one thing that you can neglect or you can do. A lot of places neglect it or have always neglected it. What unit tests are a way for your code is code to test code. So when you're doing a deployment every 3 seconds, you need to be sure everything works. I don't know how their tests run every 3 seconds. Or if they're smart enough, if they're smart enough to say what files did this touch, what unit tests cover those certain files, and only run those, what they do. That'd be cool. So your developers talk about test coverage. It's very easy when you write a story to say, I want more developer time to be spent delivering visible features. And you can do that for a while, but then eventually you're not going to be able to make sure everything works. And QA's job turns from an hour a day to a whole day to make sure everything on the site works. So you can also check test coverage. Test coverage is saying, I've got 10,000 lines in my code base. How many of those are actually tested by unit tests? So here developers talk about that file has poor test coverage or it has good test coverage. That means how much of that file or area identification is actually tested by unit tests. Unit tests versus functional tests. A unit test tests a very isolated thing without any external dependencies. So it'll test just a class to make sure it works properly without your database or anything else. Whereas a functional test may actually say, hey, does logging actually work on a live site, for example? There are 2 different kinds of things. This will figure out what exactly broke. This will be your first flag if big things are broken. This is the rule. CDN, you'll hear this term too. This is Content Delivery Network. So we have our HTTP diagram over there. There's the one web server, right? But let's say I get 10,000 hits a minute. That web server would crap out, and every single request all over the world is going to one point. CDN is a way of actually saying, the things that are on my web server, I want a copy of those stored on thousands of servers around the world. So when you hear things like Akamai or CloudFront, for example, what that actually is creating copies of stuff on your web server at thousands of web servers all around the world. So when you're in Japan and you request an image or a video file, it doesn't go all the way to my US server. It actually goes to a closer server in Japan to get the actual asset and serve it back to you. And then there's 2 things. Their network is faster, it's a shorter trip, 3 things. And then also my servers have to handle that traffic. So occasionally the CDN will ask my web server for a copy of the new version. The downside there is that, let's say I launch a new version of my website, the old version is still cached all over the world. So there may be an expiration period where you have to wait for that to expire, or you tell the CDN to say, hey, clear out the old version.
Is that expensive?
It depends. CloudFront's relatively cheap, but at the same time, it will reduce some of the bandwidth on your actual web server because the requests aren't making it all the way to your actual web server. But the end result is faster responses for people too. People really care about how fast things load now. CMS, we probably talked a little bit about this, command systems. There's 2 kind of ones you'll see, which is kind of interesting. This is a really fun debate lately. Decoupled versus traditional CMSs. So traditional CMS manages how everything looks on your web pages. A decoupled CMS says my only job is to manage the content, and I'm going to give it all to you via an API. Then you write your own application or your own apps to then actually use that content how you want. So a really common scenario is I've got tons of content. I want it on a website and on an app. So if you had already decided how your content's supposed to look on a web page, you couldn't serve it to your app. So you make your content agnostic to how it's actually used and say, okay, here's the title and body and something else. Then the app can ask for that, or the website can ask for that. That's more of what we design these days, because then your front-end team doesn't need to learn CMS, which will make them really, really happy for the most part. So some CMS terms, some CMS to run into, Drupal, Sitecore, Expression Engine, Craft, Adobe AEM, used to be CQ. All different tech stacks, PHP, .NET, PHP, Java. So a lot of times your CMS choice will be dictated by your already tech stack choice. So that is actually a good point. So if you started as a product company with a startup, but eventually you need a CMS, your CMS may end up being whatever CMS runs on your platform. Because you might say, I don't want to run Java and Ruby, I'd rather just run Java, so we're going to go with Adobe AEM, for example. So that is a really good thought. JSON. This is essentially a format for describing a chunk of data that's also native to JavaScript. So everything that talks to most other things in the internet these days mostly wants JSON. Your developers will say, okay, that API gives me a response in JSON. So XML is the old version of this, which is not just kind of fallen out of fashion. It's easier for both front-end and back-end work. So essentially, it's a universal format for describing key value pairs and then arrays as well. So a JSON object might have, I can make a JSON object for, you know, a blog post. That'll have a title attribute, it'll have a body attribute, and maybe a comments attribute that has like an array, so multiple comments underneath it, for example. REST. REST is essentially an API we probably mostly work with, and it delivers stuff in JSON format. So the same way I asked for google.com/calendar, I can ask for google.com/API/calendar. And instead of an actual table that looks nice to me, it might give me a chunk of JSON with all of my calendar events. And what I can do there then is say, okay, I have my own website. I'm going to take that JSON from google.com/API/calendar and then reformat it and do whatever I want. So a lot of things you'll see lately are all about remixing other services or using other services, and that's usually done through REST API, serving JSON. API is application programming interface, and it's all about apps talking to apps rather than users. Where I was at, I did the whole startup as API first. So what that means is every single piece of functionality was in an API, and you build apps on top of it. So then you go to build the mobile app, you have the whole API there. If you got acquired, they could actually just integrate easier because everything's an API, for example. Frameworks, we talked about tech stacks like PHP, Ruby, and Python. In those languages, you can actually choose to use somebody's boilerplate set of code. So a lot of the problems we solve in applications are very repetitive. So it's like, oh, you have an application with login. No one's ever solved that before. So a lot of what you'll see is things like Rails, Django, they're all Symfony and Zen, which I'll go into what those are in a second. We'll have like the built-in authentication solution. Or they'll have the built-in way to connect to Mongo or MySQL. Or they'll have built-in management for sessions and cookies. Otherwise, you can write that all from scratch. And if you're someone who knows Rails, you go to someone else's Rails project, it's very easy. If everyone wrote their own Ruby framework, it'd be a mess to jump between projects as well. So there's front-end and back-end frameworks. Some front-end frameworks to run into, same thing for JavaScript. They make writing JavaScript easier and more fun. So jQuery, Angular, React, and Backbone are some ones you'll run into here. Sure, good.
For learning, would you suggest not learning the framework first and learning the actual, like for example, learn traditional JavaScript before you go into, say, jQuery or
Great question.
Angular?
Absolutely. I started to do Rails, then realized I had to back out and learn Ruby first. So that's a really common thing with Ruby on Rails, particularly too, because it's very easy to be eager to build features, and then you're just kind of learning the framework. So I would absolutely advise learning the language before the framework. I really, really would, because you'll understand it better. So some JavaScript frameworks we'll use. Angular was Google's big project for a while, which they just went off with. jQuery is everywhere for the most part at this point. Some people don't like it. Front-end frameworks change every month. Our front-end team wants to use something different every one of those. Rails is one we talk about a lot. Django is probably one of the largest Python frameworks you'll see. Laravel is a leading PHP framework. Symfony is another PHP framework that my project uses. Zen is another PHP framework as well. You'll hear the term model view controller. Has anyone ever heard that term before? Cool. So a lot of frameworks use this pattern which is models describe how data is structured. I have a blog post, for example. Controllers say, okay, give me these blog posts at this time when I want them, and views essentially make your HTML look a certain way and push your blog post into your view. So that's a common pattern. Not all frameworks follow that, but it's very common with backend frameworks in particular. Refactoring. This will be one that will annoy people. So developers will commonly say we need to refactor things. What does that mean? It means I designed this the way I thought was correct last sprint, or per requirements. The requirements changed. It's no longer the right way to have this work. And it might still work functionality-wise, but as far as like from a cleanliness code standard point, you'll look at it and be like, this is a mess, or I don't want to do it, or I don't want to keep building this. So there's no way around refactoring. That's the truth, in my opinion. So the right approach is to have good unit test coverage and then encourage refactoring. And there's two ways you can do it. You can say, you get some sprint points for refactoring this sprint. So I was somewhere where we said, hey, we get 3 points every sprint to do any refactoring work you want to make something better. And essentially making developers' life easier in the future. You're cleaning up someone else's mess. Refer to the Boy Scout rule of code, which is leave it cleaner than you found it. So if you touch it and it's messy, try to clean it up. Or develop sneak refactoring work in and not tell you. Which if you have good test coverage is fine. If you don't, that's not fine. If you don't have a refactor, you accrue technical debt, which is just more and more of a mess. The phrase I like to use is, do you know the cost of owning a mess? Which is, over time, something becomes worse and worse and worse and more messy, and then developers say, we can't refactor, we regret it from scratch, which is an even worse scenario. So I'd say balance refactoring work, but then listen to your team when they say, we really need to refactor this, especially if they look at the product roadmap and say, you want to do this next month, we have to refactor this first. So definitely ask software engineers about refactors as part of the application if you have dependencies on new work as well. It'll make your team happier too. Refactoring is pretty fun in general to do, and it gives you a good feeling if you're a software engineer. So if your team needs a boost, just tell them like, hey, what do you really want to fix in this application? I'll go pretty quick. IDE and editor, this is where you edit code. Essentially the tools that you use to edit code could be Sublime Text, PHP Storm Eclipse, anything like that. That's only 30, right?
Yeah.
Okay. Dependency management, I can skip that for now. Cool. So, a few things. Questions and answers, anything at all you guys have, I can answer. Catherine, push and touch me if you have more questions afterwards. And I can also show you some live web pages on what I work on and ask questions of the tech stack. Cool.
So, when somebody has a title of an architect, so if you are an architect, what does exactly that mean? I know that in terms of building, but I don't know that in terms of software.
It means something completely different in every organization. So, I used to think my job was two things. I used to think it was technical quality and project success. So, if I don't write a single line of code, but the work is good and it's on time, I did my job. More lately, I think it's that and also making sure the team is happy. And you'll have really highly technical PMs sometimes, so you need to do less of that work with them, or you have PMs who are very good people and people management, so you have to do less of that. So in general, a technical architect divides the work that needs to be done and reviews it to make sure it's good. So a product manager might not have the insight, they might not know, put your models using controllers here, but a technical architect can tell the other developers how to actually do that. So essentially organizing all of the coding work that will happen, and then also advising the product manager on technical architecture changes that need to happen for their features to make it. So Catherine might say, we really want to do this new feature, and I'll go, well, we don't have any way to support it. So we need to actually investigate what we need to do or buy to support the new features. It might be some whole new database or some whole new API. So they're essentially responsible for the technical delivery of whatever we're developing for the most part. And it varies wildly with companies. Some technical architects never code, some code most of the time. It varies drastically.
So, so your stakeholders are the development team and also the PM people, but they're not like clients. Clients, you don't directly work with clients.
I directly work with clients a lot, but at the end of the day, my stakeholder is a product manager. If they're a good product manager. If they're a good product manager, I should not care at all what the client thinks or does. If they're good.
Occasionally.
Yeah, but a lot of times, like, our client has their existing technical architecture, which is a little bit of a pain, so very often I'll have to talk to the client to explain why we can't do things, so it would be unfair to ask a product manager to do that.
Or if the client has technical people and
Yeah.
they really just want to talk to a technical person, sometimes you have to like those two people up top.
So as a technical architect, like, what is your ideal product manager?
Clarity and vision and driving stuff forward, I would say, is not being indecisive, saying like this is what we need to do and driving it. So not like alternating the vision for what we're building every other week, I'd say. Like this is the long-term vision, I have it in my mind, we want to launch it by this date. I understand the subset of features that need to be built to get to that vision, is what I really, really like in a product owner, I'd say. Is that level of clarity, and then also being able to articulate stuff really clearly, be that written or verbally. Being able to describe to developers who might not get it, what they actually need to help them build.
Any other questions?
Who works harder, a product manager or a developer? You're not allowed to say it depends.
Who works harder? Is that what you asked?
And he says not allowed to say it depends.
Because you do both.
You could just not say it.
I guess you don't.
Depends on your definition of working hard.
Yeah, it depends on. I mean, I'm very big on reasonable team hours. So what's working hard in a day. A lot of product owners I know will clock more hours than some developers, but some developers will also clock heavy hours. Because I think a good product owner will really, really care about how good it is. Whereas sometimes developers, like myself, will sometimes want to just develop the features that were assigned to them. So it depends. There are developers who have much more product owner tendencies, or if you're at a startup and you're doing everything and you really care and you work your ass off. But if you're some developers will say, I'm just going to give my tickets and go home, whereas a product owner might say, I have this vision. So if they're really good product owners, maybe the product owner works a little harder. If you're a developer in a smaller place, you can clock heavier hours. So yeah, it depends a lot on who the product owner is, I'd say, the developers do. But as far as working harder, I'm very, very big on reasonable team hours too. It's always my approach for stress.
You mean just like work-life balance generally, like?
Yeah, like 40 to 50 hours a week, usually close to 40.
And if you're working harder than that, you better be at like a really, really small company or like.
You're doing something wrong.
You should have a stake in the company. You're doing something wrong to the client. You're not setting expectations, which is not even the product owner's job. It's a little bit of their job, but most of the PM. I mean, the other thing too is developers. It's a really good time to be a talented software engineer, and you'll burn people out in GitHub. So be really, really conscious of, if people are burned out, cut them some slack, yada yada, all that kind of stuff, because people will burn out and they'll go to another company. That's the truth about developers right now.
It's really good to work for you.
What'd you say?
It should be fun to work for you.
Thanks, I appreciate that. I've gotten good feedback from a lot of people that I'm nice to work for because I'm quasi-manager, quasi-software engineer, and I'm pretty happy doing that. So I've gotten a lot of nice feedback. Thank you.
What's a good developer job? Sorry.
There's two. I know a good one. There's two kinds of programming languages. The ones everyone complains about, and the ones nobody uses. That's probably my favorite. Everyone's like, "Oh, this technology is better." I'm like, everyone's like, "Node.js is better." I'm like, because there's not too many large Node.js apps out there, except for Uber at this point. So the more people use them, the more they complain. So as soon as people use it a lot, they complain about it. That's it. Cool. Any other questions?